Alright, so this is 9.1 sequences in series, day 1. We're going to talk about summation notation. So that's the sum of the first n terms of a sequence is the series n equals 1 to k of an, and that's going to be equal to the first term plus the second term plus the third term plus all the way up to that kth term. So that's where the k comes from. It's because it's the last term. Example number 1 says write the notation for the sum and find the sum. So write the notation for the sum. I'll do that in green, and that just means expand this out. So plug in 1, 3 times 1, because our series starts at 1, and go all the way to 5 because our series ends at 5. So this is what it would be. And then we could go ahead and expand that out. So it would be 3 plus 6 plus 9 plus 12 plus 15. And this would be our first term, second term, third term, fourth term, and fifth term. Then you could add those all up. So you get 45, and that would be our sum. Okay, the next one is going to be the series that starts at n equals 3 of 1 plus k squared and ends at 6. So we're going to go ahead and expand it. 1 plus 3 squared, because that's where our values start at. And then you keep on going until you get to the last one, which is 6. Okay, then you're going to go ahead and add these up. So that gives you 10 plus 17 plus 26 plus 37. Okay, then adding those up, you're going to get 90. So just to recap this, 10 is the first term, 17 is the second term, 26 is the third term, and 37 is the fifth term. So I could ask you for any one of those, and I could ask you for the sum. Okay, then we have series. So we have two different types of series. We have series that are finite, which just means that, for example, A and B here, they ended at a certain, or there was only a finite number of terms. So we had 5 terms in the first one and 4 terms in the next one. Then we have infinite series, and those go on forever. So instead of a 6 here, let's say for B, you would have infinity. So let's go ahead and write out the example here for number 2. So example number 2 is for the series that starts at 1 of 3 over 10 to the k all the way to infinity. It says find the third partial sum. That means the sum of the first 3 terms. It's only the partial sum because it's only the sum of the first 3 terms. Okay, so that would be plugging in 1, 3 to the 10, plus plugging in 2, 3 to the 100, plus plugging in 3, 3 to the 1000. Then you could write these out in decimals. Okay, so that would be what you would get when you would add those up. Then the next one says find the sum, which means find the sum of all the numbers from 1 to infinity. So we're just going to kind of expand this part here and try to imagine the pattern here. So the next one, if we follow the pattern, is going to be 0, 0, 3 plus, that's the next one has another 0 in it. And you could keep on going. Eventually, it's going to sum up to, if you add these all up, it's 3 going on forever, which is the same thing as saying 1/3. And in the next 2 lessons, we're going to find actually a formula that's going to give us the 1/3. But for now, you should be able to do anything that's that has a denominator on the bottom. And you'll practice some of those on your homework. So next we have a word problem here. Alright, so this is example number 3, compound interest word problem. An investor deposits $5,000 in an account that earns 3% interest compounded quarterly. The balance in the account after n quarters is given by an equals 5,000. 1 plus 0.034 raised to the nth power for n is equal to 0, 1, 2, and 3. 1 says write out the first 3 terms of the sequence. So go ahead and do this, pause the video, and then go back. Alright, so here are the first 3 terms. 0 would be the initial balance, and then you have a 1. So 1 quarter has passed, and 2 has been 2 quarters have passed. And finally, find the balance in the account after 10 years by computing the 40th term. Well, let me just explain how they get 40. If you have 10 years and you're talking about quarters, that's 4 quarters every year, then that would be the 40th term. And plugging in 40, your balance after 40 quarters would be this raised to the 40th power, which is going to be, let me plug that in. Alright, and that's going to give you a 19,045.46. So that's how much money you'll have after 40 terms based on this formula right here.